right, well, I tried to record this during my actual class, but it didn't work. So I'm going to go through this. I did post the notes already that we took, but I'm going to kind of go through it again real quick so that we have a good record of what we talked about. So new thing that we're going to talk about today is if two triangles are congruent, their corresponding parts are congruent. We kind of already understand that. You guys have done that before. We know that if I have a triangle here, I'm going to do an easy one. If I have something like that, if these two triangles, if I've got angle, side, angle, if the triangle on the left is going to equal the triangle on the right, that means then if it's a 4 down here on this section, then the section on the right, even though we haven't said it's congruent because the triangles are congruent, we know that it should be equal on both sides. So we have a shortcut for writing that. We put it like this. Close. There we go. We say congruent triangles imply congruent parts. So if the triangles are congruent, then all of their parts are congruent. That's all that means. So we do have, or I'm going to put this on here, flowcharts. I'm going to put a quick practice question here for our blue sheets. If you already have, or if you don't have this filled out yet, or if you don't have your blue sheet picked up, obviously pick this up or get your blue sheets at some point and you can fill this out. So we're going to see a bunch of these today. So here's a quick example to start with. The difference between this flow chart and what we've done in the past is that if you notice, there are more levels to it. It's not just a level of 3 across the middle and then 1 across the bottom. Oh, I wish that darn thing would go away. There we go. We can see we have a single level up top. Then we have our 3 across the middle, our 1 across the bottom, and actually we're going to do one more. So we went from 2 levels, 3 across the middle and 1 across the bottom, to 4 levels, 1 on top, 3 in the middle, 1 below that for our triangles, and 1 below that. So the reason we have 4 levels is because now we are going to put everything we've been given into the flow chart, which we haven't before. Before, if we were given parallel lines, we didn't actually include that in the flow chart. We're going to do that now. So we're going to start with saying PQ is parallel to RS. That has been given to us. What does parallel do? If we have parallel lines, then we are going to have alternate interior angles. So we need to say that this angle is equal to that angle. Oops, too fast. This angle is equal to this angle because of our alternate interior angles. So, or because of our parallel lines make alternate interior angles. And so that's what we're basically saying here. We have parallel lines and we are going to make our angles equal, which would be angles on the top. To say by Q, we would say angle PQR. So we follow it down. PQR follows all the way down. Equal to on the bottom, or we're by point R, so we would need to say SRQ. Those angles are equal because the lines are parallel and they make alternate interior angles. Okay, so that's kind of what that does with our flow chart. The next thing we can see, we have been given angle PRQ. Notice that's different than the one we have over here. We had PQR, now we have PRQ. They are different. So PRQ is this blue angle in this picture that we have is equal to angle SQR. Again, different than SRQ. So we have these angles that we were given. We have these angles that we found. I'm going to put given in there. That's how we know it. And we can tell they do share the middle of that segment of that triangle. So we can go ahead and say R, that's the letter, RQ is equal to RQ. That is our shared and or reflexive property. Shared, you could call it reflexive, one or the other. You don't have to put both. I'm putting both so that you guys can see that both are correct. And that would be a side that is now congruent. And we can see then very quickly, clearly, we have congruent triangles because they have angle, side, angle. So we're going to need to just say which triangles are in fact congruent. So triangle, now here's the trick. It doesn't say triangle PQR or anything like that. We have to say it. So if we wanted to, I'm going to go with RPQ. Why not? RPQ is congruent to triangle R starts at the bottom left corner. And so that is going to match with, that's the blue angle that they started us with. So we need to start with the blue angle from the other triangle. It's been kind of rotated, it's twisted around. So R starts with the blue, so Q will start our blue for our other triangle. P was the obtuse angle, so we're going to go to S, and then we're going to bring it around to R. And we can see our reason for that is our angle side angle congruence. And so then we've got one more box. Well, what are we going to do with this last box? What was it they asked us to do? Let's go back. What are we trying to prove? We want to prove that angle P and angle S are equal. Well, if the triangles are equal, if two of the angles are equal, then all of the angles are equal, because that's how congruent triangles work. So we now know that angle P and angle S are going to have to match each other, and we're going to prove that. We're going to say, because we know we have congruent triangles, angle P is congruent to angle S, and it's not that we were given that, and it's not that we're trying to prove that. What allows us to prove that? Well, we know the triangles are congruent, and so that's where we get this new part here. Congruent triangles, if the triangles are congruent, then that's what this arrow means. All of their parts are congruent. So we're going to say congruent triangles implies congruent parts. And there you go. Okay, so that's kind of how we're going to fill out our flowcharts today. That's what we're going to be using and be able to kind of put it all together. So let's take a quick look then at our next couple of problems. So to start with, we're going to talk about more proof with triangles today. Chapter 7, day 2. I know it's day 2. Some of you haven't done day 1 yet, and that's because of our snow day. So, because day 1 is fun and we want you to be able to do it, and it's got a lot of activity and we want you to be able to enjoy that. So we skipped to day 2. If you haven't already done day 1, you will. Okay, so for each of these diagrams below, we want to decide, are the triangles congruent? If they are, state which method and find the value of x. If they're not congruent, or if there's not enough information, state not congruent. Okay, so we can see in our first picture here, we know that both triangles are sharing this side in the middle. They both have 8. We can see that we've got congruent marks, so this segment is equal to this segment, which also happens to be x, so we know this side's x. And we know that this angle is a 90-degree angle, which means the angle on the left is also a 90-degree angle. So are the triangles congruent? Yes, they are. This would be, we have a side, an angle, and a side. So we do have SAS here. So we're going to use that and say that right here. We have congruent triangles by side, angle, side. So if we have congruent triangles, do we have enough information then to figure out what x is? Well, if the triangles are congruent, then the 10 on the left and the 10 on the right should match. And so therefore we have a right triangle where we could do Pythagorean theorem. A squared plus b squared equals c squared. So 8 squared is 64. 10 squared is 100. I'm going to subtract my 64 to both sides. And I'm going to get x squared is 36. So if I square root, x is 6. Okay, it's just a multiple of our 3, 4, 5 triangle. So hopefully not too terrible. Just kind of doing some of the things that we've been doing in the past. If you need to pause or rewind, feel free to do that. On the next one, we want to know, do we have congruent triangles? Well, we do have angles that are equal. They give us that much. And we do have lines that are parallel, which we just saw in the last flowchart, or on the beginning of the notes. If we have parallel lines, then we're going to have more angles that are equal. And we do see that they share the side in the middle. So we do have congruent triangles. This would be our angle side angle. So if we know the triangles are equal, do we have enough to say that all of the parts are equal? Yes. So that means the top would be 9, so the bottom would be 9. If the left side is 10, then the right side, which is what x is also 10. And there we have. So that's not too terrible. Solving for x. If the triangles are equal, then everything's equal. What about on the next one? So we have both triangles have an 11 So we have congruent here and here. Both triangles have a right angle, and both triangles share the middle line. And so this is that really weird one. This is that HL theorem. So we do have congruent triangles, which means that if this angle up at the top is 35 degrees, then the angle at the bottom is also 35 degrees. And so that means we can label our opposite and adjacent, because this is going to have, we have an 11 is a side, x is a side, we have an angle. Anytime an angle and a side and a right triangle kind of go together, that means it's a sine, cosine, tangent problem. Since this is O and A, we're going to do tangent of 35 equals our opposite, which is 11, over our adjacent, which is x. So I'm going to grab my calculator here real quick, and I'm going to solve this. If I cross multiply, I'm going to solve 11 divided by, there we go, tangent of 35. So I get about 15.7 here on that solution. I know that I'm going to divide because I can't multiply 11 with tangent of 35. So that means I'm going to have to divide, and I should get 15.7. All right. You're never going to do tangent divided by a number. You're always going to do a number divided by a tangent. Same thing with sine and cosine. All right, last one. Do we have congruent triangles? We do have an angle that's congruent. We have another angle that's congruent. So we have similar triangles. We have a third angle. We know the vertical angles are congruent. But we don't have angle, angle, angle. That's all we have so far. The 4 is just going to match with x. It doesn't actually say that 4 is equal to x. So while we want them to be equal, it doesn't say they're equal. And so we can't say that we have congruent triangles. So nope. So that means we don't know what x is equal to, and we can't solve that one. Ta-da! Okay. So that's just sort of some brief, like, kind of reviews type stuff from a while ago, from chapter 6, and even further, some of our other solving strategies. And so then what we are going to look at now is how can we take that information and put it into our flowchart. So we've already kind of seen that. So let's take a look at a flowchart. Notice the flowchart we're looking at here should be pretty familiar to one we just did. That's actually the same problem right up here, part B, from our problem just a second ago. So we already know that our triangles are congruent by angle, side, angle. We just want to put that information into our flowchart, which is what we did at the beginning of the hour, or the beginning of the notes too. So this is just showing you how to use some of the new properties and some of the new levels on our flowcharts. So we're going to go ahead and start by saying we have parallel lines. AB is parallel to DC. That was given to us. And if we have parallel lines produce alternate interior angles. We need to say what angle is this in the top corner. So that angle would be ABD. And it would be equal to the angle in the bottom corner down here, BDC. And it's not that was given to us, but we know they're parallel. The lines are parallel. So they produce alternate interior angles that are equal. We've also been given that angle ADB, which would be this one, is equal to angle CBD, which is this one. And we're just going to add that. ADB is equal to angle CBD. Okay, notice they're very close, but not quite. That was given to us. And lastly, we do know that they are sharing through the middle. We know that BD is equal to BD. That is that shared or reflexive property. Again, you don't have to put both. I'm putting both because I want you to know that they mean the same thing. So because we have all of that information, that is enough to say our triangles are congruent. Notice it doesn't actually say we're proving that. We're going to go beyond that information. But if we can prove they're congruent, then we can say everything's congruent. So we're going to say triangle. Why don't we say bad? Let's say the bad triangle, BAD. Okay, the first one doesn't matter. It's up to you how you list it. It's the second one that has to follow suit, though. So if I go B has the double angle mark in the corner. A is way out in kind of nowheresville, and D comes back around to the blue mark. So we need to make the same markings, same statement down below. Green out to nowhere, up to blue. So DCB would be our congruent triangle. And we know they're congruent by our angle side angle property. So then what if we have congruent triangles? What does that allow us to say? It means that everything's equal. So we are trying to prove that AD, that 10, is equal to BC, the x, which is what we solved for earlier. And so that's what we're going to do. We're going to say AD is congruent to, or you could just say equal to, CB. And that's because congruent triangles make congruent parts. You can go ahead and write down the actual reason. You could write because the triangles are congruent, but this is meant to be a shortcut, a symbolic way of writing the same thing you could write in a sentence. So this is just to make it shorter. If you don't like the abbreviations, you can write it out. It just means that you'll have to write outside the box, kind of like I already did. Okay, so that's that. So it's got, I think I've got like a couple more, just some more practice with some flowcharts, nothing crazy. Like I said, similar to what you've done before, but also some new bits too. So our next one, different triangle, same kind of stuff though. We've got some pieces that are given that don't actually say congruent, but it's going to give us some congruence. So let's start with that. BD bisects, so that's something from our last test that we talked about, angle ABC. That was given to us. What does that mean? BD bisects means it cuts in half angle ABC. I'm going to redo that. Hold on. Let's see here. Let's make that a little nicer. BD ABC. There we go. It's just a little harder to do that. Okay. Handwriting's not the neatest thing in the world for me. All right, so if BD bisects ABC, that means this top angle by point B has been cut in half. It's been cut into 2 equal parts. So we're going to need to say what 2 equal parts we have. So we can see on the top left, we have this angle up by point B, and on the top right, we have this angle up by point B. We're not going to say B is equal to B. We're going to say angle ABD is equal to angle, you could either go CBD, which is what I'm going to do, or you could say DBC, which is fine too. Again, it was not given to us that that's true, but we know it's congruent because that's what bisect means. That's the definition of bisect. That's what the word is for, to tell us that things are equal. So that's a pair of angles that we know match. We also were then given angle A and angle C match. So we're going to just go ahead and mark that in there. Angle A matches angle C. That's been given to us. And lastly, of course, we're pretty used to this one. They share the middle. BD is equal to BD. That's that shared or reflexive property. Okay, so that's a side that we know has to be equal. So that then is enough to say we have congruent triangles. Let's say, how about bad again, the bad triangle. Our bad triangle, BAD, top, out, in, BCD. They're congruent, and we can see we've got our angle side congruence this time. If the triangles are congruent, then all of their parts are congruent, including AB, this part, and BC, that part. AB must equal BC, or be congruent to. Again, because congruent triangles imply congruent parts. There you go. So that's just a new kind of level to our flowchart. All right, I've got one more real quick, because the more you do it, the easier they get. So now we have some more information. We can see here we actually have 2 parts that are going to start us out. we have E is the midpoint of AD. We've seen midpoints before. E is a midpoint of this AD or DA. So I'm going to start with that information. E is the midpoint of AD. That's been given to us. What does that mean? If E is the midpoint, that means it's right in the middle, and they actually already marked it for us. That means that DE is equal to EA. That's what a midpoint is. So that's our definition of a midpoint. And that gives us a side that's equal. We also know that angle A and angle D are both right angles. So I'm going to add that. It doesn't actually say that A and D are equal. I'm going to write RT for right angles. That's our given. And so what does that mean? Well, if they're both right angles, they're both 90 degrees, which means they're both the same. So we can go ahead then and assume that angle A is equal to angle D. Because right angles are all equal. Now, I'll just put the word equal. All right. Is there anything else that we can conclude is equal in this problem? We can go ahead and look at our vertical angles in the middle. They are sharing point E, but they are not sharing the angle. So we need to say that it's angle DEC is equal to angle BEA. Angles in the middle, that pair, those are the vertical angles. Oops. Here we go. And then these were our angles as well. So now we can see we do have enough. We have 3 pieces of congruence. 3 pieces of congruence is all we need to say that we have congruent triangles. And so let's go ahead and say, how about beautiful, BEA, the beautiful triangle. BEA is congruent to, that would be our CED. And that would be, we can see here, our angle side angle congruence again. All right, so then, what are we trying to prove? Well, if the triangles are congruent, then is AB, this side here, equal to DC? Should be. AB is equal to, or we can do our congruent symbol, DC. And again, because congruent triangles implies congruent parts. Okay, so hopefully nothing too terrible here, nothing, mind-blowing or world-rocking, earth-shattering. It's just using what we've already done and adding some new stuff to it. Okay, a little building block here. All right. Let's do one more. The only thing that's different about this next one is actually the same proof, the same flowchart, but it's written as a 2-column proof. So it's the same thing, but instead of bubble, bubble, arrow, arrow, bubble, bubble, arrow, arrow, all of that stuff, it's written in column form. Some people prefer this method. It is up to you guys if you want to do this way. Most people just prefer to use our flowcharts because that's what they're used to. But you're going to notice it's giving you the exact same information. It does allow you to condense a little bit. Here we've got both of our givens in one statement instead of separating them out like we do in our flowcharts. There's our givens. So they're kind of starting them out both in one bubble instead of 2 different bubbles. Then they can see angle A is equal to angle D. We've already got those in here. A and D are equal because angles with the same measure are congruent. We said right angles are equal. It's the same thing. We also then would have our definition of a midpoint, which is that DE and EA have to be equal. Okay, because a midpoint makes things equal. And then we have our vertical angles, which were these DEC and AEB. Those are the vertical angles. So you can see it's the same thing, it's just formatted slightly differently. So if we have our angles are equal, then that means our triangles are equal. I think we had our beautiful triangle, BEA, is equal to, we had CED. And that would be, again, our angle side angle reasoning. So it's just left to right instead of top down is kind of how these ones get set up. And so then we would be still proving that AB is equal to DC, or CD, I'm going to say. It's the same thing. And that, again, is our congruent triangles imply congruent parts. So some people really like two-column proofs because it gives them more space to write, whereas instead of trying to fill it into this little tiny circle, some people really like the flowcharts because they can kind of logic it out a little more. They have an idea of what they're supposed to be filling out at what level. So it's really up to you which one you like better, but they both do the same thing. The ultimate goal is to give us some information, some background that allows us to then prove other pieces of information. And that's all that is. So that's the end of the notes. So if you haven't filled yours out yet, make sure you do that, and you can work on your homework. Good luck.